Hello everyone, and welcome to today's Tigera webinar, Extending Firewalls to Kubernetes to Not Break Existing Security Architectures. I am pleased to introduce today's speaker, who is Amit Gupta. He is the Vice President of Product Management at Tigera. Amit is responsible for the strategy and vision of Tigera's products and leading the delivery of the product roadmap. He has expertise in building software products and services across cloud security, cloud-native applications, public and private cloud infrastructure. And he holds an MBA from the School of Business and a Bachelor of Technology in Mechanical Engineering from IIT Kapoor. So, before I hand the webinar over to Amit, I have a few housekeeping items that I'd like to run over. So today's webinar will be available on demand after this live session is over. It takes about 5 minutes, and then you can watch it again if you want to, and it will be accessible through the same link that you got to get here. Second of all, we'd love to hear from you. So we love interactivity. We like questions, and I encourage you to ask as many questions as you want, and please ask them when you have them, and we will try to answer them when they come so that they're relevant. That being said, we will hold a time at the end for Q&A, and if you have questions, we can then finish off any questions we didn't get to, or if you have new questions, we'll get to them there. So this webinar is scheduled for an hour, although it can run over as long as 70 minutes. So without further ado, let me hand it over to our presenter today, Amit. Amit.
Thank you, Michael. Good morning, everybody. Very excited about this topic we have today. As Michael mentioned, feel free to ask questions during the presentation. But for today's session, what I've done is I have split the discussion into 3 parts. The first one will talk about how users, customers are managing network security using a zone-based architecture, some topics that might be very relevant for some of you. So we'll start with a quick primer on that. The second part we will focus primarily on if you are running a containerized based workloads, specifically on a Kubernetes-based infrastructure, how does that break or create challenges for you as you are implementing a zone-based security for these workloads and applications? And then last but not the least, we will walk through a specific approach on how you can actually extend your existing security architecture to Kubernetes-based workloads. At the same time, keep your investments in your existing tools and processes, but have a more fine-grained security and compliance posture for these workloads. So that's how we have planned the agenda for today. There's a lot of topics here, so I'll jump right into this. So let's start with a very brief and a quick primer on security zones. Now, in your specific organization, in your security teams or your networking teams, you may have a slightly different naming convention, but here, at least in this illustration, I have taken some basic examples of what we are seeing across various Kubernetes teams and users, enterprises deploying security zones. So in this example, you can see that my entire infrastructure is split across 6 different zones. You could have only 3 different zones in your environment, but let's run through this one by one. So starting with the first one, this is your public internet. This is what you call as your untrusted zone. This is where you are essentially protecting traffic coming from the bad guys into your internal networks. The second aspect here is your semi-trusted, your DMZ. And typically, this is where you're putting or hosting your user-facing workloads, where you're accepting traffic from untrusted zones. This is also the zone where you would be hosting your partner-facing workloads, any business apps that you need to be able to give access to your partners who are outside your corporate network. You would be hosting those workloads in this specific zone. The next one is the trusted zone, and this is where you are hosting applications, typically your middleware components, typically your business apps that are essentially just need to be accessed inside your network for your internal users. You will also be hosting in this trusted zone applications that provide the middleware component to your user-facing workloads. The third zone, which is marked as restricted zone in this illustration, is essentially where you're hosting your crown jewels. This is where you put high-risk applications, highly regulated infrastructure, and any customer data, any confidential data that is relevant for your specific organization. That's what you would put in a restricted zone. In addition to these three zones that we talked about, your DMZ, your trusted zone, and restricted zone, we often see examples like the management zone. And this is where, in this specific security zone, you are hosting workloads that are related to your IT infrastructure. This could be your virtualization infrastructure, this could be your backup infrastructure, your monitoring components, your infrastructure services, and they're all sitting in this management zone. And then last but not the least is the audit zone. This is where you're hosting, let's say, some of your security ops infrastructure, your security incident and event management tool, your event correlation systems, your telemetry data, your centralized logging infrastructure. So again, the specific zones and how they're grouped, quite frankly, varies across various different enterprises and how you've designed the infrastructure.
Amit, I hate to interrupt you for a second. We're having some audio difficulty. So apparently there's an echo in the line. So what we're going to do is just take a quick pause. Amit, if you could dial back, if you could hang up and dial back in, that would be great.
Okay.
I'll keep this open, and we'll just wait for a minute, and then get started right back up where you left off. Okay?
Sounds good. I'll do that.
Okay. Thank you, everyone, for holding. Thank you, everyone, for holding on, and thank you for the person who asked, "Is there a speaker?" We heard quite an echo, so Amit will dial right back in, and we will restart the webinar shortly. This is the first time this has happened to us, so interesting. So, okay, I will mute my line now, and we will get started in just a minute.
Michael, this is Amit. I'm back through my cell phone. Is this better?
Well, I'll leave it to the audience. So why don't you go ahead and pick up where you left off? If you have audio troubles out there, people, if you can't hear, that may be your settings. But if you're getting something that's very bizarre, an echo or a repeating delay, please let us know, because that's a Bright Talk issue and we need to address it with them. Okay? So without further ado, Amit, it's all yours.
Great. Thank you, Michael. Apologies for the technical issue. So where I left off was I described various different zones that we typically see in an enterprise network security architecture. Now let's go from there to how do actually these zones get applied and used in an environment. So the most common approach that folks will use is there will essentially be a profiling of your application based on the type of application, the risk profile, the type of access, and who needs to be able to access these resources. And once you profile the application, however and whatever the criteria are, then you essentially
host those applications based on those similar risk profiles. So for example, if I have a certain component of my application that needs to be accessed through public internet, well, I'm going to host that application into my DMZ. Or if I have a crown jewel or a enterprise app that I absolutely do not want to be anywhere near to public internet, I'm probably going to host that into restricted zone. Or an application that needs to be able to access a customer database that I have within my enterprise, I'll probably host that in my restricted zone, and so on. So most enterprises would essentially profile their applications and then host these applications into these respective security zones. The one other aspect that is important to know is that how do you actually do the access control and visibility across these different security zones? So there are quite a few models out there. The most common one that we see among our customer base is you would use a set of firewalls to be able to prevent or allow access from one zone to another, do that granular access control, and then also use the same firewalls to monitor the traffic going between one zone to another. So that's the most common model. Now, if some of you are wondering, well, that's a very kind of architecture, and we're hosting our applications in the cloud, and that's not applicable for us. Well, let me show you what we have seen across the cloud as well. So irrespective of what tool or technology you're using to do access control and monitoring across these different zones, there are models in cloud as well where you can enforce and implement these zones in your cloud-based hosted applications. I'm not going to go through a detailed architecture of how it is done in this example in Amazon Web Services, but this is just an example to show you that people are implementing a zone-based network security architecture. Even in the cloud, they may or may not be using, let's say, virtual firewalls, and might just be doing that through security groups in the cloud-based infrastructure. Here are some similar examples from Azure, and then I have one more illustration that shows how you will set up a zone-based architecture in Google Cloud Platform. So, there's various different ways you can implement a zone-based security, either on-prem or in the cloud, and we'll double-click on specific areas where a containerized-based workload creates some challenges. But I want to quickly summarize why you're putting this zone-based architecture in place and the key aspects there. So start with primarily you are establishing access control and boundaries for various risk and security zones that you have defined for your applications. You are enforcing controls around how to manage inter-zone communication and enforce policies that require you to isolate workload from one zone to another. You're leveraging these tools and processes to monitor any network traffic across these zones. So primarily because you're trying to detect any violations there or troubleshoot any network connectivity issues. And then last but not the least is if there are indeed gaps and violations, then you want to be able to remediate and contain communication both inbound and outbound from these zones. So that's the basic set of controls and visibilities that you have put in place. Now let's go to the second part of the discussion where we will spend time on understanding how do these zones actually apply to a Kubernetes-based infrastructure and what specific challenges users run into. So before we go into the specific network security for Kubernetes workloads, I want to compare and contrast how containerized applications running in a Kubernetes-based infrastructure is different from your traditional applications running in a virtualized form factor in a VMs or even in a bare metal server. So typically these traditional applications, they are long-lived, they are stateful, they are not changing as frequently as we are seeing in these modern microservices-based applications. So there's a well-defined, rather static identity for these applications on the network. Now, when you compare that to microservices-based applications or microservices-based architecture running in a Kubernetes-based infrastructure, these applications, the form factor is containerized. They are highly dynamic. They are stateless for most part. They are ephemeral, and they are short-lived. So what this implies is that any approach or any architecture that relies on the network identity of these applications to be IP address, those approaches are not going to work very well to enforce any kind of security architecture, let alone security zones. So that's the key point I want to make here. And then now let's jump into what does it do to your security zones? So in this illustration, I'm showing you a Kubernetes cluster. That cluster is hosting workloads from 3 different zones. You have some workloads that are categorized for DMZ. Then there's workloads that are categorized for trusted zone. And there are some workloads running that are categorized or have been profiled as restricted workloads. Now, you have your user traffic coming in from outside world, and that traffic has to go through your firewall and the security that you have put in those firewalls. By the way, if this is in the cloud, these firewalls could be native security that you get from the cloud provider, could be security groups and whatever your cloud provider is providing. And once the traffic goes through this security layer, it hits your whatever Egress solution you're using inside your clusters and then goes to your DMZ. Now, from there on, if some of these workloads running in your DMZ zone need to talk to your trusted workloads, typically you would again send the traffic through a firewall and then filter it through the firewall back to your trusted zones. Now, again, I'm using the word firewall here, but this applies to your cloud-based infrastructure as well. So you might be managing this through security groups or firewall rules in Google Cloud Platform. We've also seen customers do quite unnatural things to enforce these security architecture in a Kubernetes-based environment. Sometimes they would separate out your DMZ workloads and trusted workloads into separate clusters. Sometimes they would put them in a different or use different IP pools for these different zones, and then manage security through these firewalls based on those IP pools. All of those approaches are suboptimal and create a strain and challenge in terms of how you automate deployment and security for these workloads. So continuing on this illustration, if let's say your trusted workloads actually do need to talk to some other cloud services that they may be consuming or other parts of your software as a service infrastructure, any traffic leaving the trusted zone going outside to public world is again enforced through firewalls. Now, because these firewalls or security groups, they don't understand the identity of Kubernetes workloads, then what you end up doing is you create big set of IP ranges, open that for your firewall, or allow access from all your worker nodes, your Kubernetes worker nodes, to be able to consume these cloud services. In effect, you do not have a mechanism to enforce any fine-grained security there. And then last but not the least, if you need to send the traffic from trusted workloads to restricted zone, you'll follow the same approach as send the traffic through the firewall and create some latency for your application. But that's really the model most folks have used. Now, there are three main technical problems with this architecture. First is these firewalls or security groups, they do not understand the identity of Kubernetes workloads. So you have to rely on a non-cloud native mechanism to segment the traffic. So either IP addresses, or you taint your nodes to only run certain types of workloads, certain zone workloads on your Kubernetes worker nodes. So some non-cloud native operational procedures you would have to deploy. The second aspect is because these tools and technologies, they don't understand the Kubernetes identity, your visibility of traffic inside these clusters is quite limited, specifically any traffic going from particulars across these zones. And the third aspect is it creates several performance issues and operational issues as you are hosting these dynamic workloads in these clusters. Now, how it manifests for you from a security perspective is that now the granular security architecture that you have in place for your traditional applications or non-Kubernetes-based infrastructure cannot be enforced in a Kubernetes-based environment, because these security zones that you are now replicating through firewalls or through security groups is going to have to be very coarse-grained. The second aspect is any fine-grained access control that you are implementing for applications consuming cloud services and so on cannot be enforced in a Kubernetes world, and it doesn't have to be just the cloud services. No Kubernetes application is running in an isolated environment. They need to have access, or they may have workloads that they need to access that are in your data centers but outside your Kubernetes-based infrastructure. How do you enforce granular access control for those workloads? And then last but not the least is you do not get any workload context or metadata for your network traffic. So you are always missing the context of which pod, which namespace, which application is consuming or is tied to this particular network traffic. And the compliance actually goes across all of these aspects. So how you enforce your security control set, and how do you manage your evidence data and your audit information to prove compliance. While you may have been doing that for your traditional applications through those firewalls or security groups, it's hard to enforce that and manage compliance for Kubernetes workloads using those existing tool set. So that was a quick summary of the specific challenges you run into when you are enforcing a zone-based architecture, a zone-based security or network security architecture in a Kubernetes environment. Now, what we'll go through is we'll walk you through a particular design pattern, how you can, how you can enforce these security zones in your Kubernetes-based environment and continue to use your existing tools, processes, and models in place. So let's walk through this again. Here is where you are with respect to your current security zone architecture. Now, a couple of things to call out here. In this model, as you can see, any traffic that is going from a pod to another pod inside the same zone, you literally have no visibility or access control there. So the first step there is that you put network policies in place for each of these workloads and manage security and visibility for all your traffic within the zone using Tigera Secure, and I'll walk you through how that's done. So that's the step one to that, is within the zone, all your traffic you basically whitelist, you get the visibility from Tigera Secure, and now you know exactly what's going on inside your cluster and specifically inside each zone. Now, for your traffic that leaves the zone, so for traffic from DMZ to trusted zone or trusted to restricted zone, you can again implement the same set of policies, a fine-grained access control, all enforced at the source on the pod using Tigera Secure. So if, let's say, you have an application where front-end can talk to back-end and back-end can talk to the database, the policies associated with your coarse-grained zones and also your fine-grained policies with respect to each application, those could be defined on individual pods and applications. Now, you can still continue to use your firewall or security groups if you want to for coarse-grained security. If you got IP pools that are associated with a specific zone, you can continue to allow coarse-grained traffic from one IP ranges to another IP range, but fine-grained security could be enforced using Tigera Secure across those zones. And then the third aspect there is essentially any traffic that is outbound to either cloud services, outside your network cloud services, or API endpoints, or traffic that is outside your clusters, outside your Kubernetes cluster, but still within your data centers, you could enforce fine-grained security and visibility for that traffic using Tigera Secure. So to summarize here, the key distinction between what the security posture and compliance posture you had prior to implementing Tigera Secure is that you now have fine-grained security, you have deep workload context visibility for all the traffic, and you can enforce some of the compliance control set at the same time, keeping your existing zone-based architecture. So essentially, you will be able to extend a full zone-based network security architecture, however you have defined in a fine-grained way onto your individual Kubernetes workloads. You will also have access, you will also be able to enable fine-grained network security policies for egress access to cloud services, API endpoints, or your infrastructure inside the data center, and then you get full workload context on that. So that's a very typical design approach that we deploy to enforce a security zone architecture in your environment. Now, let me walk you through a little bit about Tigera Secure and how do we make this design pattern implement, or how do we implement this design pattern in your environment. So before I go into the details of Tigera Secure products, it's one thing, it's important to call out that our security architecture and the solution we provide works across your entire infrastructure, irrespective of where you're running your Kubernetes clusters. You or your dev teams may be hosting these clusters across the major cloud providers or inside your data centers using one of the most common commercial distributions out there. Will provide you a federated security across all your clusters. So if you want to enforce policies that red can talk to green, it doesn't really matter where red and green pods are running. We'll be able to provide you a granular security enforcement and visibility across all your clusters. Now, there are three key aspects of our solution that enables this zone-based architecture across your environment. The first is a true zero-trust network security architecture where you whitelist all the rules and all communication for your Kubernetes-based workloads. We provide deep visibility and threat detection for your clusters. And last but not the least, a continuous compliance across all your Kubernetes environment. So unlike your traditional approach where you have a snapshot-based assessment of your compliance rule set, we provide continuous enforcement and continuous visibility across that infrastructure. So let's go into each of these solution areas in detail. So when we talk about Zero Trust network security, there are four major principles of our solution. The first is establishing trust on individual pods and services based on multiple sources of identity data. We look at cryptographic identity of the workload and also the Kubernetes identity of the workload before we establish trust and say this is indeed an accounting service or an accounting pod. The second aspect is implementing a model of least privilege. And the way we do that is we provide a unified policy model where you can define fine-grained security rules all the way from layer 3 to layer 7 for your application. So you can go as granular as your security architecture demands, all the way down to specific URLs and web methods in defining the whitelist rules. The third aspect is the defense in depth architecture, where we do enforcement of these whitelist rules at multiple points of the infrastructure. So in an unfortunate situation where if your infrastructure gets compromised, your application stays secure, or if a particular component of an application gets compromised, your infrastructure stays secure and the rest of the infrastructure and applications continue to stay isolated. And then last but not the least is all data in transition across these clusters will be encrypted. And that gives you a very good security and compliance posture in terms of all your Kubernetes-based environment. The second aspect is around visibility and threat detection. So oftentimes you would need access or visibility inside your clusters for various use cases. You're either looking for any indicators of compromise or indicators of risk inside your clusters. You are trying to troubleshoot a network connectivity issue and figuring out if you have some network fabric issues, or you got the policies wrong, or you just need some log data and audit data for your compliance or for your evidence information for your rule set. So we provide deep visibility, starting with the first thing, which is very rich flow logs. And the flow logs provided by Tigera Secure, they have the entire workload context, including your Kubernetes metadata. So for each connection inside your cluster, you'll be able to see which pod, source destination pod, namespace, labels, policies applied, policy action, connection bytes, connection count. So a lot of rich context available for each of the flow log or each of the connection inside your clusters. We also monitor your infrastructure, your cluster traffic, and your audit logs to detect any kind of anomalies or malicious traffic. So if we see any kind of port scans, any kind of IP sweeps, any kind of recon activity inside your cluster, we'll set that up as a anomaly alert for you to further research. We will also integrate with your threat feeds, and we'll also provide a threat feed built into the product, and we'll block any kind of known malicious traffic, giving you a very comprehensive threat defense inside your clusters. We also provide a visualization interface. So, for example, if your developers need to troubleshoot a particular service incident and they're trying to figure out if they have a misconfiguration or a misconfigured policy, they can navigate down to their individual workload in a specific namespace and figure out which policies are applied. And it's very handy when you're trying to troubleshoot any issues or service incidents. And then last but not the least, all this telemetry, all these alerts, all the data can be sent to your security operations center, to your log aggregation platform, or whatever your security orchestration workflows are. It could be integrated right into that. The third aspect of our solution is around compliance. So as you are preparing or planning your architecture for, let's say, PCI, SOC 2, ISO 27001, or whatever that compliance regulation or control framework that you use, the first aspect is you take that control set or the compliance requirements and map that to specific security controls that you will enforce in your Kubernetes-based workloads. So we provide a mapping for various different compliance frameworks to specific network security controls. We provide you Kubernetes RBAC-driven controls and access controls around managing these security controls. So if you are setting a set of compliance controls from your security teams, how do you make sure that your developers, as they deploy workloads and policies, they don't tamper with the security controls around that? So we provide granular RBAC controls around that. Any non-compliance to these security controls that you have implemented would essentially be raised as a real-time alert on any rule violations. So it's relatively easy for you to track any non-compliance events rather than relying on a periodic assessment of your environment that is done on a weekly, daily, or monthly basis. And then last but not the least is we provide detailed guidance and evidence reports. So as you are preparing for your audits for specific compliance programs, you have detailed visibility into your in-scope assets, the policies, and the rules enforced for those assets. So that gives you a very strong set of capabilities to manage compliance for your infrastructure. So that's in a nutshell a quick summary of all the capabilities and how you implement a zone-based security architecture using Tigera Secure. Michael, I'll hand this back to you now.
Yeah, thank you, Amit. That was great. If we have any questions from the audience, we will go ahead and field those now. I'll give you guys a couple seconds to type in any questions you have. I know we covered a lot of ground, and I know this is something new, extending Kubernetes firewalls and with being able to use it with zone-based architectures. So this is great stuff. So you may have some questions. If we don't, we're not the kind of company that will put in fake seed questions. So if we don't have any questions, we will go ahead and end the webinar. So just about a couple more seconds. Apparently, we have a webinar that is attended by nothing but security experts. So we are good. No questions. Okay. With that, I'd like to thank you guys all for attending. Amit, thank you so much for presenting. And one thing also, as you see on the slide here, we have a whole host of webinars that are available not only through our Bright Talk channel, but on our website at tigera.io/webinars. Two of the webinars I'll call out that are some of our most popular and also some of the best content. One of our most popular on-demand webinars is the top 5 best practices for Kubernetes network security and compliance. That is available on our webinar site and at the URL you see there. And also, really, this is a must-see webinar. This is a joint webinar we did with AWS and Atlassian. And this is about Atlassian's, it's basically an Atlassian case study about their journey from a monolithic application to the cloud and microservices, and how they did that with AWS and Tigera in a secure manner. And it's a really great story. They go into very technical details. So it's a great webinar to watch. So I would encourage you guys all to have a look at those and peruse the other webinars we have on our site and the other content, white papers, and so forth. We try to be very best practice based here, and so there's some good information. Oh, we do have a question while I was rambling on there. So So Amit, can you see the questions? The question is this based on Kubernetes network security policies as a foundation for the controlling flows?
Yeah, absolutely. So yes, that's definitely true. So we in Tigera Secure, we implement security architecture based on Kubernetes network security policies. In addition to that, we also have Calico network security policies, which actually provide you an even broader set of capabilities. So if you want to be able to define your network security rules from layer 3 to layer 7, you could do that through Calico policies. But fundamentally, to your question, yes, this architecture and the solution is implemented as the Kubernetes network policies, and that's definitely the foundation for managing the flows and also providing the visibility. Okay.
Well, if there aren't any further questions, I'm going to give you 18 minutes of your day back. And yeah, so that's it. Amit, thank you so much. And everybody, thank you so much. Once again, this webinar will be available on demand very shortly afterwards. If you would like a copy of the presentation, you can go ahead and email, if you got an invite, at reply@tigera.com. And that will go to me and to our team, and we will reach out to you and get you a copy, okay? So, thank you for attending, and we will see you at our next webinar coming up soon. Thank you, and goodbye.